This is video on limit state method, single reinforced beam, and we are going to look at fundamentals and formulas in this case. So, you all must carefully look at these three figures. Understand them carefully and also remember them. Left side figure shows a beam, rectangular beam of dimension B and D, where D is effective depth. XU is the depth of the neutral axis. Above neutral axis there is compression zone, below neutral axis there is tension zone, and AST is steel, the single reinforced steel, which is at the depth of D from top. That was leftmost diagram. Central diagram is a strain diagram, and now ISCORE has specified freeze this diagram. That is, if you see at the top, maximum strain in concrete will be 0.0035. Then up to 0.002, the stress strain will be, between these strains, it will be a horizontal line. And then after that, it will be parabolic. So these strains are specified, and look at the bottom. Maximum strain in steel is 0.87 Fy upon X plus 0.002. This is a design course, and we don't need to get into how and why this has come. We can accept and apply. That's the aim of this course. And look at the rightmost diagram. Stress diagram, remember, in elastic method it was triangular stress diagram. In ultimate load whiteness method it was rectangular. Now with the whatever wisdom has prevailed after this is a stress diagram, a combination of a rectangle and parabola. Okay, and now this you see the upper 0.446 FCK, that is the maximum stress that concrete can take. FCK is that value, M20 it is 20, M30 it is 30. Now this diagram will be a vertical line till 3/7 of XU, and for remaining it will be parabola, and the corresponding strain at that time will be 0.0035 and 0.002. Now if you work out the area of this diagram, it will come to 0.36 FCK, 0.36 FCK. And if you look at the location, it will be at 0.42 XU. And at the bottom, the steel stress will take not as Fy but 0.87 Fy. As I said, these are specified in ISCORE, this strain diagram, stress diagram. We are expected to accept it, learn it properly, and then apply. Now, if you look at, let's say, our usual, how to find neutral oxygen, it is total compression is total tension. So total compression will be 0.36 FCK XU, that is the force, and 0.36 FCK XU into B. See, 0.36 FCK is the resultant, and see XU and B is the area. So 0.36 FCK B is equal to 0.875 Fy stress into AST. So from this you get this formula for finding neutral axis. Now lever arm will be what? D minus this 0.42 XU. Now these two are going to come handy for solving the problem. Now you know what this specifies, like ultimate load theory. It specifies maximum depth of the neutral axis. Beyond that you can't go. There is nothing like over reinforced. So this is worked out by this formula. See, this is a strain diagram, and this the left hand side of this equation comes, or this is simply similar triangles, this formula, and from this you can work out XU maximum by D for any Fy. Ex is constant for steel, which is the value 2.1 into 10 raised to 5 Newton per, Newton per mm square. That's right. Now you have XU maximum by D. So now among the steels we'll be dealing, there are 4 types of steel, but we'll be dealing only with 250 and 415. So now see, you have a way of finding XU maximum. It is, how much, for M250 it is 0.53D, and for 415 it is 0.48D. Remember, ultimate load, maximum XU or maximum depth on electric axis was 0.5. So it is 0.53 and 0.48 in this case. Now, this is the minimum underenforce. For underenforce, the minimum still they are specified by this formula, even if you don't need it. Okay, then we'll have balanced. We'll work out a balanced section, but we'll never have overenforce. If you need, then you need to go for double reinforced. Now, balance section formula calculations you see. Here is the stage diagram, total compression equal to total tension, you work out XU, you work out Z, and moment resistance will be total compression in the lever arm or total tension in the lever arm. So if I take concrete side, it will be 0.36 FCK XUB, this is a concrete, concrete force into the lever arm. Now, little bit of simplification and adjustment, and then putting XU as XU maximum, if you do, then you can come up with a simple formula of mu limit equal to Q limit Vd square. And this Q limit for various concrete and steel we can work out. Say, put in this formula for these, this Fy and this M20. And you will find that it's easy to work out, because for 415 XU maximum is 0.48D, and for Fy250 XU maximum is 0.53D, and you will not be dealing with any other steel in this course. So you have this mu equal to QBD square. Say for example M20 concrete, it is 2.76, M25 3.45, and M30 4.1. For at the end of the day, it is better to remember, and you will automatically remember these 6 values, or Q, or Q limit, or M equal to QBD square. That Q you will remember. It will come handy for you. And this has come from this formula. Okay. Now, if you are to deal with under reinforced, because only two type of problems will have, either balanced or under reinforced. So under reinforced we'll go through some derivations. Looks complicated, but then at the end it comes out handy. So here is, because it is under reinforced, I have written mu from the steel side. We have worked out XU. Then we have written mu, and there we have substituted XU. Okay. Then we have made some adjustments for some good reason in terms of for this formula, that is making it mu upon 0.87 F5BD square, and then taking it further, we want to express in terms of PT, that is percentage steel. So AST is equal to PT BD upon 100. So we have written expression in terms of PT for good reason, that we wanted it to be in quadratic. And then finally we get PT as this, a formula to be remembered. If you are do it more accurately, this 1 instead of 1, it can be 1.005 also, but you usually use 1. This formula is to be remembered, and see how we use it. Let's say I want to find PT limit for M20415. So the Q limit is 2.76. That is mu by BD square is 2.76. You substitute in PT. See, we have done that in the last step, and you get PT limit 0.96. And then for this standard, see, you will be only dealing with 3 type of concrete and 2 steel. And for these, using this formula, you will have the PT limits. Now, these will be very handy for you to very handy for you while solving the problems. Okay, this formula look complicated, but then you see if you remember the results, it will be good for you.